All right, this is specifically for the students who missed class today, um, specifically the seniors. I had several that was absent, and then several attended the senior breakfast. Y'all need to make sure that y'all have watched this, and you may have to do it repetitively just to make sure that you're competent in knowing how to add and subtract rational expressions. You also need to watch the video on solving rational equations. To start with, you've got to make sure you're good with getting a common denominator. To get a common denominator, you got to make sure every factor is covered from the denominator. So what I'm talking about is in this particular problem right here, you have, 8 is just 2 times 4, and then you also have an x, and then here you have 4, and this is x times x. Well, if you think about that, you have to have everything here in the common denominator. That means you got to have a 2, you got to have a 4, you got to have an x, and you got to have another x. So everybody here has to be covered. If you multiply all that together, that is 8x squared. So you may want to break it down like that into small pieces, or you might be able to just roll with it in your head. You want the smallest number that both 8 and 4 go into, which is 8. And then basically, of your powers here, you want the biggest power. The way the numerator works out, it's always the same thing. It's whatever your numerator is, and then the leftovers. And then whatever the sign is, we have a minus sign here. And then you're going to do it again. Numerator, and then your leftovers. Okay, now I have to explain to you what the leftovers are. Your numerator's 3, and then let's do parentheses, and then we got 11. And then here's the leftovers. You want to look at your original denominator, and you want to look at your common denominator. What do you multiply your original denominator by in order to get your common denominator? So basically, what are you missing? You need one more x. Well, that's the leftovers. Go to the next one. You got 4x squared. What do you need to multiply that by to get 8x squared? Well, you need a 2, so put that up here. Once you got that done, it's kind of like you went over the hump. That's the hard part. You just need to clean up your numerator at that point. That's just going to be 3x minus 22, and that's 8x squared. There's nothing you can do with 3x minus 22. There's nothing common that you can factor. There's nothing you can reduce. You are done. This is your answer. Okay, it gets a little bit different when you have binomials. If you have binomials in your denominator, you need to factor first to see if you have a repeated factor. Kind of like, let me go back to the other one. See, in the other one, we had repeated factors of x, and we had repeated factors of 4. If you factored this, you have x plus 1 and you have x minus 1. And I'm okay with you, kind of cheating a little bit and just do it in under there instead of rewriting it. That's okay. Now come down here. Let's do common denominator. You have to have both of these factors in the common denominator. I'm hoping that it's clear that the x minus 1 is a repeat. But x plus 1 has to also be in the common because he appears in the second one. Now, remember our structure. You got to have your numerator, leftovers. Whatever your sign is, numerator, leftovers. Now go back and ask yourself, what's missing? What is missing from this denominator to your common denominator? Common denominator has an x plus 1. Well, that goes here. What's different from this one to this one? Nothing. Since they're the same, you put a 1. Once you get all that structured, multiply the top out. 9x plus 9 plus 4. And by the way, never, ever, ever multiply the bottom out. It kind of makes you go around in circles. There's no sense in it. Just work with the numerator. If nothing happens with your numerator, then you can stop. You can't do anything with 9x plus 13. There's nothing you can factor, nothing you can reduce, so this is your answer. You're done. I mean, the point is, if you can factor something out of 9x plus 13, you are supposed to factor it and reduce. And sometimes that does happen. I do believe this one is going to do that for us. Check out this denominator. You can pull a d out. That leaves us d plus 3. All right? So when you start looking, we have a repeated d plus 3, but this denominator also has a d, so he has to be included. All right, so let's do our structure. We have numerator, leftovers, sign. Now, since this numerator is a binomial, make sure when you write that numerator down, wrap it up in parentheses, because you're multiplying that entire numerator times whatever's left over. Okay, now go back and figure out what is left over. Okay, check out this denominator, compare it to your common denominator. Well, the difference is this d, so put d up there. All right, check out this one, the factored form, and your common one. They're the same, so put a 1. Now go through and multiply your numerator out. You have d squared plus, well, when you multiply by 1, that's going to be the same, 5d plus 6. Excuse me. All right, now remember what I said. Keep the denominator factored. All right. When you do that, let's get some space here. I hope you notice that that numerator can factor. What two numbers multiply to 6 and add to give you 5? 2 and 3. Signs are the same, both positive. So you pull it apart and look at there. We have a repeated factor. We have d plus 3 in the top and d plus 3 in the bottom. And if you remember from what we did earlier with reducing radical expressions, as long as you have one factor in the top and one factor in the bottom, you can reduce. If it's attached with a plus or a minus sign, it has to be the entire factor. So we have d plus 2 over d. You cannot reduce those d's right there because d plus 2 is attached with a plus sign in the top. There's your answer. But just know, sometimes you can continue factoring and reducing at toward the end of the problem. All right, it can get a little bit longer. Like this one has 3 portions. Doesn't necessarily mean it's harder, it's just a little bit longer. All right, and if you notice, we do have d minus 5, d plus 5. You should have been suspicious when both of these were d minus 5 and d plus 5. You're assuming that those things are going to repeat. They're kind of like little hints out there. Now, since you have 3 fractions up here, you're going to have 3 sections. So you're going to have 4 leftovers. Put your plus sign. 3 leftovers. Bring down your plus sign. 8 leftovers. So is everybody following the structure? There's our 4, there's our 3, there's our 8. And the plus signs are coming from right there. Now go through and figure out what you need. Look at this denominator, common denominator. They're the same, so put a 1. This denominator, common denominator. I am missing a d plus 5. This denominator, common denominator. I'm missing a d minus 5. All right? Now multiply the top out. Leave the bottom alone. Now, don't get lazy and not write the bottom. If you do that, you're going to mess up your problem. So it's going to eat up your paper, but you're going to have to write it anyway. And all you're doing is distributing, guys. Once you get it distributed, you want to collect your like terms. Let's see here. That's going to be 11d. 4 and 15 is 19, and a negative 40 is a negative 21. We have a d minus 5 and a d plus 5. There's nothing you can factor out of the top. We are stuck. So there you go. That is all there basically is to adding and subtracting rational expressions. Review it. Come see me if you have questions. But it's basically all about that common denominator. Have fun practicing.